Okay, in the past few videos we've learned how to name ionic compounds. Today we're going to learn how to name acids and bases. Before we get too far in this process, we haven't actually defined acids and bases, so let's do that first. There are multiple definitions of acids. We are going to stick with the simplest one that we possibly can for this level of a course. Okay. Acids are defined as any compound that has H plus, which is just a proton actually, as the cation. Okay, so we talked about cations and anions, so this is technically almost an ionic compound. There will be charges involved. Okay, bases are any compound that has hydroxide, which is one of the polyatomic ions, as the anion. Okay. In terms of real-world practicality, there's something called the pH scale, which if you take Chem 2, we're going to see in excruciating detail. And the idea is it runs from a pH of 0 to 14. 7 is neutral, so not acidic or basic. As you get lower on the scale, it becomes more acidic, and as you get higher on the scale, it becomes more basic. Okay. The more acidic something is, honestly, in terms of real-world exposure, your body is designed to eat acidic things, so things like lemons are like a 1, 2, or probably more like a 2 on the pH scale. A thing like a can of Coke is like a 1.5 to a 2, depending on concentration, all that stuff. Vinegar is like a 4, 3 or 4. Your blood is like slightly above 7, it's actually slightly basic. Things like bleach is like a 12, ammonia is like a 10, just in terms of real world examples. Okay. We are mostly worried right now about how to name these things. I just wanted to have at least define them once. Okay. So in terms of naming acids, there is a naming scheme. There is a set of rules on how to do this. It's almost easier just to give you the names of the most common acids and just have you memorize them. I know I hate asking you to memorize a bunch of stuff, but it's almost easier to do so in this case. So, HCl is basically H is the cation, Cl is the anion. This is hydrochloric acid. The naming scheme, I guess I could tell you, is if it's not a polyatomic ion, it's hydro, whatever the anion is, instead of IDE ending, it's ic acid. So hydro, instead of chlorine, it becomes chloric acid. If you have HBr, this is hydrobromic acid. So instead of the IDE ending, instead of bromine, instead of bromide, it becomes bromic acid. Okay. Most of the ones you're going to encounter are actually polyatomic ions. So HNO3, NO3 is nitrate and has a -1 charge. The hydro part isn't part of that anymore. If it has a polyatomic ion, it's just, instead of nitrate, it becomes nitric acid. Okay. Instead of H2SO4, it becomes sulfuric acid. H3PO4 is phosphoric acid. Okay, and then the weird one, which is the weird one on our polyatomic list, it turns out for organic molecules, it doesn't actually write the H in the front. It tends to write it, it's attached to this oxygen, so it writes it right here. This is acetic acid, also known as vinegar. Okay, I will tell you that I had my first chemistry class in 1994. I have used these 6 acids at least 99% of the time. So if you just know these 6, Sitting around spending hours and hours learning all the intricate naming schemes is really not worth the hassle. These are by far the most common assets. If you know these 6, you're good to go. As far as naming bases, just name them as salts. Name them as ionic compounds, because they are salts. So for example, KOH is a really typical strong base. This is potassium with a hydroxide. It's just called potassium hydroxide. There's nothing special in terms of naming bases. Sodium hydroxide is another really common base. Okay, they don't have special names, so we don't have to do anything extra to fix this. Okay, all right, thanks.